Add audible to all of you. Nafisa, Sneha, and Hamza.
Yes, sir.
Okay. So, anyone have any doubt from the previous lecture that we were studying about the elimination reaction?
No, sir.
No doubt. Okay. So, no, sir. Okay. So, we did some question on elimination reaction. Now, I'm going to start another chemical reaction or another chemical properties of haloalkanes that is called reaction with metals. Reaction with metals. That means we are going to react this haloalkane with metals, and there are basically two types of reaction with metal. The first with we are going to react it with Grignard reagent, and the second with sodium. So basically, first we are going to talk about Grignard reagent. Does anyone have any idea about this Grignard reagent? This Grignard reagent is very reactive, and why it is so, I will explain it. See, what is Grignard reagent? This is RMGX. So basically, metal carbon bond is metal carbon. There is a bond between metal and carbon. This is magnesium, which is metal, and this is carbon alkyl group. That is also called basically organometallic compound. Organometallic compound. So you can see basically when there is a bond between metal and carbon, that is called organometallic compounds. Is that clear, everyone? And this specifically RMGX is known as Grignard reagent. Okay. Sneha and Hamza, very good. So you can see I'm going to react this. This is very reactive only because we know that magnesium is a metal which has a nature of electropositive. Electropositive metal are also known as electropositive elements because they easily donate electron. Whereas you can see this is carbon, which is electronegative, very, very electronegative than carbon. That's why this bond is polar. So basically, if I'm going to take an example, CH3, CH2Br, and if you are going to react this with magnesium in the presence of dry ether, in the presence of dry ether, we will get a compound that is known as Grignard reagent, that is CH3, CH2, and it will be MgBr. It will be MgBr, and this is basically called RMGX. X is for halogen, R is for alkyl group, and MgS stands for magnesium, which is Grignard reagent. So we can write this is Grignard reagent. So please write this. And now I'm going to talk about this Grignard reagent.
Yes, sir. Finish.
See, in this, you can see this is R and this is Mg and this is X. So basically this bond is covalent bond, and this bond is probably ionic bond. This bond is ionic bond. So there are two type of bonds exist in this, covalent and ionic. Please write it. And it's very reactive. I will show you. If there will be moisture in contact with this Grignard reagent, it will react and form alkane. I will show you the reaction, but first write it and then we will talk about it.
Yes, sir. Finish.
Very good. Everyone done with this? Now see, I'm going to write a point about this Grignard reagent. So I'm going to write Grignard reagents are highly reactive, and react with any source of proton to give hydrocarbons. Proton to give hydrocarbons. So you can see the reaction. If we have RMGX and there is moisture, you know what will form? It will form alkane, that is RH, and there will be a byproduct that is known as MgOHX. Now I am going to explain the reaction. Please focus here. You know that there will be negative charge and there will be positive charge because Mg is electropositive and this alkyl group which contains carbon is electronegative. And H2O, you can see this is plus H plus, which will, as this H2O will give proton that is known as H plus, and this is OH minus. So what you need to do is this will go to this negative, positive will go to negative, and negative will go to this positive. So what will form? R negative and H plus combined to form RH, and this negative will go to this positive MgOHX. So as you know that magnesium, oh wait a minute, as you know that this is magnesium which has +2 charge and X has negative charge. In order to balance this, neutralize this OH minus will go and add up. So together they will be -2 and there will be a compound that will form MgOHX. Now again I am going to take an example. I'm going to switch off my video because it's lagging. So see, if I'm going to take an example, CH3MgX, MgBr, and if water is going to react with this moisture, so what happens? As you know that this water will contain H plus and OH minus, and we also know that this is negative, this is positive. So this positive will go and attach with negative CH3 and combine with H, so it will form basically CH4. And again this Mg will get this OH, so it will form MgOHX. Is that clear, everyone?
Yes, sir.
Please write it and let me know when you're done.
Sir, the answer is supposed to be MgOHBr, right?
Can you repeat the answer again? Wait a minute. CH3? Yeah. Sorry.
Yes, sir.
Yes. MgOH, and here it will be Br. Yes. What were you saying about the answer? Anything?
No, sir. I was just saying that. I was just correcting that.
Okay. Let me know when everyone done with this. Hamza, why are you not responding
Yes, sir.
at all?
Finished.
Sneha? This is our main product and this is our byproduct. So we will only consider the main product. So if I'm going to give you a question, CH3, CH2, CH2Br or Cl, and if I'm going to react this with water, oh wait a minute, MgBr. This is basically MgBr. And if I'm going to react this with water, please let me know the name of the main product.
CH3, CH2, CH3
Very good.
plus MgOH Br.
That's good. Very good. So what is the name of CH3, CH2, CH3? IUPAC name?
Sir propane.
Very good. Everyone done with this? Very good. So now we are going to start the next reaction with metal that is known as Wood's reaction. Wood's reaction. Now see what is Wood's reaction. Basically alkyl halide react with alkyl halides react with sodium in dry ether to give hydrocarbons. The sodium is very reactive, that's why it is present. It is in presence of dry ether, as well as magnesium was also in dry ether because that was also reactive. So hydrocarbon containing the number of containing double the number of sorry wait a minute containing double the number of containing double the number of carbon atoms present in halide. So basically this reaction is very easy and you also have studied it in class 11th. If you have Rx, that is alkyl halide of 2 moles, and you are going to react this with sodium in the presence of dry ether, sodium in the presence of dry ether, you will get RR. Initially, alkyl halide contains only R, and we got a product of RR that is double of the uh, carbon containing in alkyl halide along with a byproduct that is 2NaX. I will explain the reaction. First write it and then let me know.
Yes, sir, finish.
Everyone done with this? I'm going to explain the reaction. See, what is the reaction basically? If you have CH3 Br and you are going to take 2 moles. First, I'm going to explain with the above equation. Rx you have like this, and 2Na like this. So I'm going to just write the opposite structure of this. XR 2 moles, we take 2 moles. So basically what happens, this NaH salt will be eliminated and this both will combine with each other. So the product will be RR and a byproduct, that is salt. So please let me know the product of this, name of the main food in the presence of dry.
So 2CH3CH2 plus
2CH2
NAD.
CH2. Please name the product. Don't tell me like this.
Sir, butane.
Very good. Is it butane? Hamza and Sneha, is it butane?
Yes, sir.
Very good. Thank you for the reply. So what happens, whatever is the number of carbon here, it will be doubled. And since it is 2, so it will be 4. And what is the name of the alkane with 4 carbon? That is butane, CH3,
Butane.
CH2, CH2, CH2. And a byproduct will be 2NADR.
Sir, what is this reaction known as?
Woods reaction. This reaction is known as Woods reaction. Okay. Okay. Let's see. I'm going to give you a question also. Now, can you name the product? Nafisa,
sir.
Yes. I'm listening.
Is it ethane?
Ethane.
I don't know. It's like CH3, CH.
See what happens here. What I just did is I'm going to write it like this. Can I write this? And just write 2Na and just opposite of this mirror image of this. And what you need to do, just extract NaCl and bond this to carbon. So what you will get will be CH3, CH, CH3, and then there will be CH, and then CH3, then CH3, and there will be a byproduct that is known as 2NaCl. Now you can see what will be the name, longest carbon, carbon 1, 2, 3, 4. So the name of the product will be 2,2 dimethyl butane. 2,2 dimethyl butane. Total number
Yes,
of carbon is just double, 3 to 6.
yes, sir.
Got it?
Yes, sir.
So now I think you can do this. Everyone done with this?
No,
Let
sir,
me
sir,
know.
write it.
Okay. Okay, please write. Now we will study about the reaction of haloarenes.
Yes, sir, finish.
Sneha, are you done with this? Okay, please do it and let me know when you are done with this. Done. Now we are going to study about the reaction of haloarenes. Wait a minute. Yes, reactions of haloarenes. So you can see reaction of haloarenes we are going to study. So in this, we have first topic, that is nucleophilic substitution. Nucleophilic substitution. So before starting this reaction, I would like to ask you a question. Or please, can you draw the resonating structure of chlorobenzene? Can you draw the resonating structure of chlorobenzene? We know chlorine has. Oh, wait a minute. Just let me write it in another. Please do respond. Can you write the resonating structure of this chlorobenzene? Yes or no? Nafisa, can you do this?
No, sir.
Okay. So see, resonating structure, resonance is delocalization of pi bond. Where there is conjugation, there will be resonance. So what happens here? This have lone pair, so this will be like this. And since this carbon is making already 4 bonds, carbon cannot extend its 4 bond, so this will move to this place. Now see what happens if this carbon is getting electron, so it will have negative charge, and this will have double bond now, and it will have positive charge. Again, you have to move this negative charge to this, and this to this bond, this carbon. Again, this will have negative charge, and this electron will come to make a pi bond. Again, what happens here? Again, this will be like this, and this bond will move to this. So negative charge will come to the left carbon, this carbon, and this will convert it into bond. Now this, again, you can see this will move to make a bond here, pi bond, and this will move again to form single bond. So you can see there is delocalization of pi bond. Pi bond in this is on the right hand side, 2 pi bond, and now you can see delocalized to left side. Let me know when you are done.
Yes, sir. Finished.
Finished, Sneha? Hamza? Oh, very good. Everyone, very good. Hamza, are you done with this?
Yes, sir.
Now see, basically this alkyl aryl halides. Aryl halides, that means there is a benzene to which chlorine is connected. Aryl halides are extremely less reactive, less reactive, less reactive towards towards nucleophilic substitution reactions, towards nucleophilic substitution reactions. Aryl halide are very less reactive towards nucleophilic substitution reaction. Why? Because we can have following reason. Because of resonance effect. Because of resonance effect. Since chlorine is in conjugation, or halogen is in conjugation with the benzene or arenes, it will be very stable. If something is very stable or it is stable, then it won't react because it is stable. So the first reason is resonance effect. The second reason is difference in hybridization, difference in hybridization of carbon atom, difference in hybridization of carbon atom. As you know that carbon atom in CH, as you saw that during resonance, you can see this is our CH3X. Oh, wait a minute. Sorry. As you saw that this is our X. So it is single bond. It is, you can see it is single bond. But since this X is in conjugation, it will be in resonance. So this bond will be basically, you can see this bond will be double bond. Now this bond will be double bond. Why? Because it is in resonance. So this bond is partially double bond character, shows partial double bond character. That's why it is not reactive. It changes its hybridization. Here you can see it is difference in hybridization of carbon atom. So please write it, then I'll explain about. We will compare this with, wait a minute, we will compare this with haloalkane, then it will be more easy. You can see H, 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 and X. So you can see this is sp3 and this is sp2. This is sp2 since forming triple bond, double bond. That's why sp2, and sp2 is more electronegative. So it will be a stronger bond than the this. That's why it is less reactive towards nucleophilic substitution reaction as compared to alkyl halide. Aryl halides are less reactive towards nucleophilic substitution reaction than alkyl halide. Please write it and then let me know.
Yes, sir.
Everyone done with this? Sneha, Nafisa?
Yes, sir.
Done. Hamza? So this is the second reason for not reactive towards nucleophilic substitution reaction. Third reason is basically instability of phenylcation. Instability of phenylcation. That means basically, if you have a benzene and this is RCN, if it will go withdraw electron from carbon, so there will be positive charge on carbon, which is extremely unstable. This is very, very unstable, extremely unstable. That's why it is very less reactive towards nucleophilic substitution. And the fourth reason we can write, because of the possible repulsion, because of the possible repulsion, it is less likely, for the electron rich compound, electron rich nucleoside to approach electron rich arrays, electron rich Everyone done with this?
Yes, sir.
Very good. Sneha, Nafisa, and Hamza. Now, we are going to do reaction with haloarenes. So basically, write a topic, a replacement by hydroxyl group. You know what is hydroxyl group? Basically, OH group, replacement by hydroxyl group. So you can see if you are going to react this with chlorine, since this is very less reactive towards nucleophilic substitution reaction, the condition for this reaction will be very extreme. Like you are going to add NaOH first at a temperature of 623 Kelvin, which is very high, and the pressure should also be 300 atm. In order to carry this reaction, you have to put this condition along with addition of H. So you will get a phenol, that is OH. So please write this. So if you are going to simply add or replacement of this chlorine with OH, you can see the condition is very extreme. You are going to have a temperature at 623 and pressure is 308. But if you are going to add OH or replace OH at the place of chlorine, and you are going to add NO2 at one of the para position with chlorine, this reactant will be basically more reactive than this. So the condition will be decreased. So in this, if you are going to add NO2 at para, so you can see the condition is decreased. Now we don't need that much extreme condition, and you will get the replacement of Cl by OH. So this will be OH and this will be NO2. And if you are going to add 2NO to this chlorobenzene, then it will be more reactive. That means the condition is also now very low. And if you are going to add 3 nitro groups in this chlorobenzene, the condition will be very, very low. You just need a warm water to react this reactant. Please write this, then I'm going to write 2 more reactions.
Yes, sir. Finished.
Are you done with this, Sneha? Please do respond. Very good. Now you can see if I'm going to put 2 NO2, one at para and one at ortho of this benzene, fluorobenzene. The condition will be, you can see, NaOH at 368 Kelvin. We need lesser temperature and the product will be easily formed. There will be OH replacement of Cl by this, and there will be NO2 and NO2 here. And if you are going to put 3 NO2 in this fluorobenzene, this is fluorobenzene, NO2, NO2, and NO2, what you need to do is just with warm water, warm H2O, and you will be replacing Cl with OH, and NO2b will be at its place. Please write this.
Yes, sir. Finish.
Everyone done with this? So this was about nucleophilic substitution reaction. Oh, wait. Hamza, are you done with this? Sneha. Now the second reaction of haloarenes is electrophilic substitution reaction. There will be attack of electrophile. So this is electrophilic substitution reaction. So how we are gonna react this? How we are going to study about this? So it's very easy. So basically, the first is halogenation. That means addition of halogen. Halogenation. That means basically addition of halogens. So if you are going to react this chlorobenzene with Cl2 in the presence of anhydride FeCl3, anhydride FeCl3, what you will get there? There will be addition of chlorine to this chlorobenzene. One will be at ortho and one will be at para. There is no resonance effect on meta. That's why there will be no product at meta. And this is basically minor. That means less stable. And this is our major product because this is more stable. It is why it is minor and why it is basically less stable, because two chlorine are nearby that will repel each other. That's why this is minor and this is major. So if you are going to name it, so its name will be 1,2 dichlorobenzene. So 1,2 dichlorobenzene, and it will be 1,4 dichlorobenzene.
Yes, sir.
Done, everyone? Everyone done with this?
Yes, sir.
Very good. Now the next electrophilic substitution reaction is nitration. That means addition of nitro group. This was halogenation. The second is nitration. So basically, nitration means nitro group addition of nitro group. So this is basically chlorobenzene, and we are going to add HNO3 in order to HNO3 in order to add NO2 in this chlorobenzene in the presence of concentrated H2SO4. So what happens here is very important. So you can see We need to add NO2 at ortho and para. Ortho and para. So can you tell me which one is more stable, which one is less stable? And also name the compound.
Second one is more stable. The first one is less.
Yes.
Sir, the second one is more stable.
Very good. So what will be the name? You can see 1, 2. So the name will be 1 chloro, 2 nitrobenzene. And here the name will be 1 chloro,
What
4
chloro?
nitrobenzene. 4 nitrobenzene. Please write it. Done.
Yes, sir.
Sneha, are you also done with this? Very good. Now we have the next electrophilic substitution reaction, that is sulfonase. We are going to add sulfonic acid. So basically, we have this chlorovenzene, and we are going to react this way. Concentrated H2SO4 and heat. So from H2SO4, there will be a group that is SO3H, sulfonic acid, will be added at ortho and para. Will be added at ortho and para. So this will be major and this will be minor. Also, what will be the name? Its name will be 1-chloro-benzene sulfonic acid. 1-chloro-benzene sulfonic acid, and here it will be 1-chloro. Sorry, no, it's not. It's not 1-chloro, because sulfonic acid is the we give priority more than carboxylic acid. This is number 1. So it will be 2-chloro-sulfonic acid, and this will be 4-chloro-benzene sulfonic acid. 4-chloro-benzene sulfonic acid. Tomorrow this chapter will be completed. So please write up to this. Then there will be a question, some questions for you. Let me know when you are done with this.
Yes, sir. Finish.
Finish. So So listen to me carefully. I'm going to share a PDF file with you. Please do this and please submit into their respective group so that I will get it and I will give marks and as well as the feedback for you. It is very important. Tomorrow this chapter will be completed and after finishing the chapter, after finishing your test, you can leave the meeting and all. Are you getting my point, everyone?
Yes, sir.
Okay. So now I'm going to share the PDF. Where it is? Here it is. Can everyone see the question?
Yes, sir.
Okay. Does anyone have question regarding this test?
Recording in progress.
Does anyone have question regarding this?
No, sir.
Okay, thank you. Can you write the question? Because it will just wait a minute. Can you write the question? First, can you write the question?
Yes, sir.
Okay, please write the question first. Let me know when you are done with the question. Hamza, Sneha. Wait a minute, please. Everyone done with the question?
No, sir.
Please write it. Nafisa,
Yes, sir.
how many questions you have written?
The third one, like one bromo propane, two bromo.
Okay,
Yes.
okay. Please guide the next one. Can everyone see a file in chat box?
Yes, sir.
Okay, thank you. So you can open that file for your test if you are unable to write it. Okay. Nafisa, Sneha, please do respond.
Sir, I can't see the file in chat box.
Okay, I just need to switch the system so it will not be shared. Okay, will it be okay? Are you done with the question?
Sir, just the last time.
What about you, Sneha? Oh, okay. What about you, Hamza? Sneha? Okay. Are you done with this, Sneha?